Okay, hello everyone, welcome back to a new class. So in the last class, we have provided with introduction for the dynamic programming based query optimization algorithm already, right? And we provide you with a high-level idea for the algorithm and also introduce a detailed mechanism incorporated to implement this algorithm. In this page, we plan to show you with a concrete example how to use this dynamic programming based algorithm for optimizing the queries. And we're still studying the joins among multiple relations, and we can take this one as an example. Let's assume we have multiple relation inputs. They are R, S, T, U. They are 4 relation inputs. And we also know the number of tuples inside the relations. They are 2k, 5k, 3k, and 1k. Here we will define the size of the join results. And here we assume the join results size T, A joins B will be equal to 0.01 times TA times TB. I hope you still remember the T is a notation, right? It denotes the number of tuples inside the relations. So this A and B, they can be any relation from the set R, S, T, U, right? And the size of the result of the joins will be equal to defined by the equation. And next, we will show you how to do the joins and how to define the optimal join trees based on these numbers we know here. So we're starting joins among R, S, T, U, right? And according to the previous dynamic programming algorithm, we have to do this kinds of joins from the bottom up. So we know the size of R, S, T, U already, and the next step will be to do the joins among any pairs of the relation among them, right? So we can define a table for computing the join results as well as the cost and the size. These 3 metrics, these 3 terms in this table. So the first column denotes the subquery you can get, and the second column denotes the size of the result. The third one will be cost, and the last one will be the plan. And for the subqueries, we have different combinations of the subqueries you can get from the ISTU. So we ignore the individual of the subqueries in this table. So we consider this subquery starting from 2 relation combinations. This subquery RS denoting the joins between R and S, and this subquery RST denotes the joins among RST, these 3 relations. And the last row denotes the joins among all these 4 relations. And the target that we are starting here actually will be to use this dynamic programming algorithm we showed before to fill in this table so we can get the optimal result for joining this RST, the 4 relations together to get the result. So I hope you still remember how we define this algorithm, also how we define size, cost, and plan as 3 metrics, right? Okay, so let's start from any pair of this combination for joins. This RS, RT, RU, ST, SU, and TUs. So according to the previous pages, we know that the size will be equal to the size, 0.01 times the size of A and times size of B, right? Also, according to the previous pages, we also define how to calculate the cost for any 2 join terms, right? The cost for P1 joins P2 will be equal to cost of P1 plus cost of P2 plus size of the intermediate result. So for the scanning result, cost will be 0, right? So we also show you with some concrete examples. The cost for R1 joins R2 will be equal to 0. However, the cost for R1 joins R2 and further joins R3 will be equal to the size of R1 joins R2, right? So based on this term, the cost as well as size. So we can fill in this table, these numbers row by row actually. We will show you how to fill in these tables in the next page.